But yes, so, well, thank you, everybody. Thank you, Stavros, for having us. My name is Rob. I am a senior software engineer working at Redactive. You've probably never heard of us before because we are quite new, and that's part of what I want to talk to you about today. So the talk is titled What We Learned Building Our AI Products. And I really wanted to just kind of go over a very high level. Under a short kind of like timeline, we kind of went from no product to we built a product and actually sold it to customers. And I want to talk about some of the engineering and business decisions we made that we kind of took risks on, and turns out, you know, they worked. Sometimes they didn't, and I kind of want to just dive into some of those a bit. Okay, cool, awesome. So really quickly, what we do, we enable enterprises to build secure generative AI apps. Our first product is essentially a real-time permission semantic search engine. So you plug in all of your enterprise data, and we can search it for you and return it back as an API. But one of the things we do differently is we do the permissions at query time, which solves a lot of problems that companies be facing. And so, yeah, so that's what we do. It's been a bit of a ride. That's just a really quick collage of all of us. We're all a little bit fun and crazy sometimes. I've also put my cat in there because he crashes a lot of meetings. And so I had to get him a tie so he look a bit professional. But yeah, so just really quickly overall, a little bit of a timeline to have some understanding of this concept. We started as a company last year. We really started working on our first product in late December 2023. I had a look at the GitHub before, and it turns out that version 0.05 was on the 23rd of December, so right before we went to Christmas break, but we got it in just before the end of the year. And we spent most of January really just having a lot of conversations with partners, potential customers, basically really getting down to what they would need in a product and what they would need to actually sign to actually sell the product to them. We've been doing that for like 3-4 months beforehand. We had actually a bunch of people go up to the US to talk to our funders and things like that to see what they thought as well. But we really started talking to a lot of Australian companies then as well. During February, that's when we really started hitting the road in terms of like actually writing the code. And in March, that's when it all got thrown out because we had to test and refactor and realize that some of our assumptions were wrong. April was really when we started to have to like grind down and actually build everything and make everything kind of come together, because on the 5th of May, we launched our product, and for our first 2 customers that signed on within that month. So I'm going to kind of just go over 3 high-level things that we did that really solidified our engineering practices. And the first one is we built with purpose. And what I mean by that is we had a very clear vision about what the end product needed to look like, and we didn't know exactly what was between A and B to get there. Obviously, there's a lot of unexpected things when you're trying to build something. But we had a very clear structure about what the end product needed to look like. And so that let us really fill it using our creativity, to a level to actually solidify a lot of those things. The code that I have on the right-hand side was some of the first code that we wrote. And all it is just it's a Python protocol file. All it says is we're just going to have a bunch of different sort of microservices that need to talk to each other. It's all in a monorepo. And this is kind of this is the high level about how those services need to, what methods they need to implement. And this kind of gave us the raw structure about what we needed to do. So for example, we knew we needed a search service, and we knew we needed a data connector service that was going to pull data away. We had no idea how we were going to build one in Confluence. We had an assumption, right? But we kind of didn't have any of those pieces built straight away. But having this structure straight away really accelerated how bringing things together later was working, because a lot of the times when you're building microservices, one of the flaws that happens is you're not really sure about what each service needs to do, and then it turns out you need to build another microservice that needs to sit in between 2 of them. And by kind of having this straight away, we were able to move really fast with that. I think the other advantage we had obviously is we're greenfield. We were building a product from scratch and not building a product from that's been around for 10 years. But again, when you have that opportunity, it's quite useful. The other thing, part of that is to keep things as simple as possible. your most valuable resource is going to be time, and you're not going to be able to do anything, especially within AI. Like it's very hypey, right? Like every new week, there's a new article on Hacker News about why some LLM is now the greatest best thing ever in the world, right? And so it's very, so you can't like obviously stick with something and say this is going to be what we're going to build. You have to be somewhat agnostic with what you're going to build. But at the same time, you also need to be able to like kind of like make a bet and like this is and make a bet on what we were going to do. And our big large bet was that RAG, retrieval augmented generation, probably sees a heads pop up, was going to be the main kind of like thing in 12 months' time. We were kind of right about that. And so yeah, we basically structured our like development with those key tenets. And kind of again, one of those things is I pulled my calendar, and this is like a very rough approximation about how much of my time was spent actually coding. And it turns out it's not a lot. I'm an engineer, and I spent 30% of my time coding. I spent about 70% of it not coding, which means that it feels like I wasted a lot of time. I look back and I go, why was I in that meeting? Turns out those meetings are important, obviously, to provide context. Like I needed to have design meetings that actually build stuff, but that wasn't actually that productive for the end product. And the third part was especially when you're trying to build something from the start, you need to remember what the business context is. I previously worked at like a bunch of other companies like AWS, and like if anybody's ever heard of the Amazon, principles, whatever it is, the first one is always like customer obsession. It's like building for what your customers want. And I think a lot of the times as developers, especially if you're in a big company, you can forget what the underlying core thing that you need to do is. One of the like things that comes out of that is like, if you're like working on a bug, how important is it to actually fix that bug? Has any customer actually complained about it, or is it just that you don't like how that CSS looks or something like that? Which is like, is important, but it's kind of one of those things where maybe it's not that important. And that's why we use a lot of like to-dos. Like if you actually did a control F on our code base right now, you probably have about 300 to-dos, which are things that we need to go back and actually like fix, but they're not actually the customer facing problem. Like our customers told us very specifically, like, we'd like the search to do X, Y, or Z feature. And so we can prioritize that in, our product, backlog. And that's kind of what a lot of our sort of like design principles were about. So I put like three kind of main things that we did when we're kind of trying to like figure out what the business processes were meant to be around what we're building. So like the first one we had is like, if we're actually trying to build something, it has to go through like, why is this going to be important for the customer? So we have like, our sessions like things like, we have a product sparring session where we all kind of like argue about what we think the most important things to do is, and bits and pads are optional. And then, if it was important, it would land on the feature roadmap, and we decide how far in the future we actually need to get it done. And then that's when we get into an issue. And then like, this is just a really quick example of what our GitHub issues look like, because if you have to make an issue, you have to explain why it's useful for a customer. And that doesn't mean that we can't put like, oh, I need to fix the linter because, the code looks bad, because that's somewhat useful to the customer because it means you're going to move faster, but you have to explain why that would work. And the final thing is just how our bug reporting works. We have to iterate pretty quickly at some point. And so a lot of that was like, we need to actually gather data as to why this bug is occurring. And a lot of that was like very quickly trying to learn how to use BigQuery and things like that to actually provide data and evidence so we could go back and say, we actually are improving the process. Sometimes it's more important to show progress than actually fix the problem completely. So there were a lot of times where we were going, oh, we've made the search 5% faster. And then the next day we were able to show it's another 5% faster, instead of actually waiting for like 2 weeks before something happened. And I think we're done. That was my last slide. That was my last slide anyway, so that works out pretty well. But yes, thank you very much. That's my thought. I will have to get down.
Oh, yeah. Wait. No. Yeah.
Yeah, there we go. Okay, cool. And if you want to hold me on to the right, thank you. Oh, sorry.
So first question about here is, are you concerned about the ongoing economics of businesses that rely on AI compute to survive?
Yes, which is why we are not an AI compute company. So we actually don't, it's actually a bit of a misnomer. We do employ AI models in sort of like the embedding and like stage like that, but we do not actually run our own models. We are kind of dependent on it for some of our business use cases. But we think there's in the long term, things are getting more efficient. The cost of an API call to OpenAI has come down by something like 80% in the last 18 months. So that's phenomenal. That's better than Moore's law.
Okay, I've got one more question here. For those two customers in that first May, how many capabilities did you have working well enough compared to what you had planned to have ready? As in, was it half the feature set? Was it 75% of the feature set?
It was 100% of the feature set because the feature set was one. We had one API call. That's what we promised. We went to them and we said, but that's kind of what it was. We kept things really simple. We said, we're going to give you an endpoint where you can enter your data, where you can enter a search parameter and you will get document chunks out. And then we came back and then we've had them recently go, we actually need this, or we need to be able to paste a link in and actually pull from that document and things like that. And we're also now working on our second product, which is a complementary item. But again, we kept things really simple. It was one API call. It seems really dumb, but that's all it was.
Okay, awesome. And the last thing I've got on Slido is just one that says great talk. So
thank you very much.